The goal of Section 6-1 is to get you used to the normal curve and how it operates and its connection with the z-score that you've calculated in previous sections. So what the normal curve is a normally distributed curve. What we mean by that is it's symmetric. It has a center to it, and both sides look the same. And by normal, we mean that it is based off of the standard score, which we have been calling the z-score. The center of any normal distribution is your mean, mu or x bar, depending on if it's a population or a sample. And the normal curve, whether it's spread out or squished in, is all determined by your standard deviation. Okay, your standard deviation dictates how spread out your curve is. What we can do is we can draw 3 lines each way that represent 1 standard deviation each way. So this right here is 1 standard deviation in the positive direction, 2 standard deviations away, and 3 standard deviations away. And then to the left you have negative, so standard deviation away to the left, -2 standard deviations, and -3 standard deviations. So that standard deviation number that we've been calculating has had everything to do with how spread out the data is. And what we've found in statistics through years and really decades and centuries of analyzing data is that we have found a way to come up with an equation of this curve, and from that equation determine how much of our data should fit within a certain number of standard deviations each way. Interestingly enough, if you calculate, let's say your mean is 10 and you have a standard deviation of 2. Okay. So a mean of 10 and a standard deviation of 2 would do this. It would be a 10 here, 1 standard deviation would be up at 12, standard deviation away would be down at 8. And if I keep doing that, that's going to be a 14 and a 16, and then a 6 and a 4. Here's what this is saying. Within 1 standard deviation each way, it doesn't matter what data you're working with. If you turn it into means and standard deviations, 68% of your data should be within 1 standard deviation each way. So that's between 8 and 12 with an average of 10. 95% of your data should be within 2 standard deviations away of the mean. That means 95% of your data should be between 6 and 14. And lastly, we have 99.7% of your data should be within 3 standard deviations each way. So what it does is it tells us how our data should be behaving, how spread out or how compact, where our data should exist. The reason that's useful is it helps us calculate probabilities. And the probabilities relate to area under the curve. Now, as you've seen, looking here in example 1, the z-score has everything to do with how many standard deviations away you are from the mean. So a z-score of 2.9 means that you are 2.9 standard deviations away from the center of your data. And since it's positive, it's to the right. So 1, 2, 3 standard deviations. That means 2.09 is somewhere right here. Just a little bit more than 2 standard deviations away. So again, the z-score is everything about how many standard deviations you are away from the mean. Notice what it says here. Find the area under the normal curve to the left of z equals 2.09. So to the left of that is all of this data here. Is all of that area under the curve. That's the area we want to find. Now, underneath the normal curve, the area underneath that curve equals 1 if you look at all the area. But I'm not looking at all the area. I'm only looking at the area to the left of the z-score of 2.09. Fortunately, we have tables in the back of our book that help us with those areas. So we're looking at 2.09. So I'm going to go to table This is Table E, the standard normal distribution in the back of your textbook. And what you'll notice is that you have a column here of z-scores that give you in this case, negative 3.4. So it gives you the ones place, and then the tenths place, and then this up here is the hundredths place. So if I wanted negative 3.44, I would go negative 3.44 is right here, and that would be the value that I'd be looking for. All of the values here in the middle, those values are area under the curve, but specifically area under the curve to the left of whatever z-score you're looking for. We're looking for 2.09. So we need to go to the next page over, and I find 2, so 2.0, so this is the row that I'm looking for, 2.09, so I'm looking for that last column. 2.09 lines up right here. So the area underneath the curve to the left of, okay, all these areas are, again, notice the shading, to the left of whatever z-score is specified. So 0.9817. So to answer this question, how much area is under the normal curve to the left of that? I believe we said that it was 0.9817. Or another way to say it is 98.17% of the area under the normal curve is to the left of 2.09. Okay. Let's do it again. Example 2, find the area under the normal curve to the right of z equals negative 1.14. So we'll draw the picture really quick. Our mean's right in the middle, and we're going to the left 1.14 standard deviations. Remember the z-score, how many standard deviations? So there's 2 standard deviations, which means negative 1.14 is about right here. And again, it's asking me to find not the area to the left, but the area to the right of that. So that's all this area here. That's the area that it wants me to find. So we're going to go to our table and find negative 1.14. So back to the negatives, negative 1.1, and then 4 is right here. So negative 1.14 lands me right at that location. Okay. So now that we have that set up, we know it's 12 or 1.1271. 0.1271. So 0.1271. Here's the problem. That area that we just looked for on the normal curve or the normal distribution table, that tells you the area to the left of any z-score. But we're looking for the area to the right of a z-score. So, as I said earlier, the area underneath a normal curve equals 1. So the value that it gave me is this here. That's the 12.71%. I want the opposite. So I need to do 1 minus that value in order to get the area to the right. So what I'm going to do is I'm going to do 1 minus 0.1271. So 1 minus 0.1271, and I'm getting a value of 0.8729. So 87.29% of the data is to the right of the z-score of negative 1.17. So moving on to our next example. This one's going to be a little interesting. It's going to take some manipulation of 2 different areas to get the area we're looking for. Because look what it says here. Find the area under the normal curve between z equals negative 1.35 and z equals 1.62. So here's essentially what we're looking for. If our mean is here, we've got a z-score of negative 1.35. So that's a little more than negative 1. and then a z-score of 1.62. That's getting pretty close to 2 standard deviations away. So the area that I'm looking for is this area between those two values. So let's go ahead and look for those values. Negative 1.35. Back to our tables. Negative 1.35. Negative 1.3. This was the 4, so negative 1.35. That takes me to that right there. So 0.0885. So 0.0885. So that's the area related to that curve. Now I got to that z-score. So now I got to go to z equals 1.62. So coming over here, 1.62. 1.62 is the third column over. So 1.62. It's 0.9474. So 0.9474, that's the area associated with that. But here's what we have to remember. Those areas are the areas to the left of those z-scores. So the 0.0885 is this area here. The 0.9474 is this area all the way down forever and ever. The area that I'm interested in is this area here. So if I simply take this area, the 0.9474, and subtract from it this area, the 0.0885, I'll be left with what I'm looking for. So to do that, 0.9474 minus 0.0885. So I'll get our calculator out again for that. So 0.9474 minus 0.0885. And I'm getting a 0.8589. So 85.89% of the data is between the z-scores of negative 1.35 and 1.62. Good. Well, we've got 2 more examples that we want to work through, and they're both related to each other. Now, I've got to set it up here to show you what we're gonna do with this. I'm going to draw a normal curve here, and I'm going to have my mean right here in the middle, right? And what I'm going to do is I'm going to draw a line right here, and I'm going to label it Z, and I'm going to cover all this area here, and I'm going to say that this area right here amounts to, let's say, let's say that area right there amounts to 0.9761. So 97.61% of the data is in this region right here that I've written. The question is, what is that z-score? So we're asking the exact opposite question. Instead of starting with the z-score and coming up with the area, I'm telling you the area, and I want you to find that z-score. So that's all the area to the left of this z-score right here. So we need to go to our table and in the area section find 0.9761. So back to that, 0.9761, 0.97, here's the 9761, there it is, 0.9761 is right here. So the z-score related to the area under the curve of that is 1.98, 1.98, and it's in the 0.08. So 1.98. This z-score right here is equal to 1.98. So at that z-score of 1.98, you have 97.61% of your data to the left of that z-score. So let's do that one more time to make sure we understand that and add a little bit of complexity to it. So again, here's our normal curve. We've got our mean right here in the middle. And what I'm going to do is I'm going to select, I'm going to draw a line right here and we'll label that our z. That's the z-score that we're looking for. But I don't want to know the z-score for the area to the left. I'm going to indicate the area to the right. Okay, to the right. So all that area to the right, I am going to say that that area right there makes up, let's say, 0.6435. So 64.35% of the data is to the right. Now, before we go to our table, we have to remember that the tables represent area to the left of a z-score. This is the area to the right. How would I find the area to the left over here? Well, to do that, I have to do 1 minus 0.6435. Because again, the tables give us area to the left. So 1 minus 0.6435, go to our calculator for that. 1 minus 0.6435, and I'm getting 0.3565. 3565. So now I'm going to go to my table, 0.3565. So 0.35, 0.34s, 0.35. Okay, so we've got an interesting situation here. 0.3565 is somewhere between these two values, isn't it? But 0.3565 is a lot closer to the 5.7 than it is to the 9.4. So what I'm going to do is I'm just going to go with the one that it's closest to. So 0.3565 is that. So negative 0.3, what? 0.37. Negative 0.37. So the z-score associated with that area is negative 0.37. So 0.6435, or 64.35% of the data is above, that's this area here that we started with, above a z-score of negative 0.37. So that's how to take a look at the normal curve in the context of z-scores and the area and what it represents. It's how much of the data, or the probability that it's greater than or less than a specific z-score.